So to wrap things up here for the module, or for the unit, and the module, we want to find sample size for confidence interval for population proportion. So our margin of error for a confidence interval for proportion is the z-value times the standard deviation here of the sampling distribution. So if we take that and solve that formula for sample size n, then we get this formula here. So our z-value squared, p prime, 1 minus p prime over the margin of error squared. So let's put this to work. So in an anonymous random survey, 28 of 100 college students admitted they cheated at least once. We want to estimate the true population percentage or proportion of college students who cheated at least once to within 1%. How large of a sample do we need with 90% confidence? So let's go ahead and grab our sample size formula and bring it down. So let's see, the 28, that is our successes, x. Sample size n is 100, that was total. And so our p prime then is going to be 28 out of 100, which is 0.28. Margin of error within 1%, so our e is 0.01. 1% is a decimal. And then we need z alpha over 2. So this is 90% confidence, so we can use the common confidence coefficient table to find that z-value. So there's the table. We see for 90% that our z-value is 1.645. And with 90% confidence, our alpha over 2 is 0.05. So that's z 0.05 is 1.645. So let's go ahead and plug in. So that z-value there is the 1.645. It gets squared times our p prime, 0.28, times 1 minus p prime, 1 minus 0.28. And then we're dividing by our margin of error squared. That's 0.01 right here. And it gets squared. So let's compute that. So we've got 1.645 squared. And then times 0.28. And then times 1 minus 0.28. Close that up. All that gets divided by 0.01 squared. So 55.34. So 55. So 55.3, and you always have to round sample size up, so 54.56. So we need a lot bigger sample to estimate within 1% margin of error.